Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and ready for that grade A. Hello, how are you? Really pleased that you've come back to listen again, or if this is the first episode you've listened to, welcome along, you're in the right place. You join us partway through a series of episodes talking about organic chemistry. And in this episode, we're going to be talking about isomerism and the various sorts of isomerism. So we're going to be defining what we mean by isomerism. We're going to talk about the various types of structural isomerism, and we're going to define stereoisomerism as well. So let's begin by defining what we mean by isomerism. Isomerism occurs where two compounds have the same molecular formula, but their atoms are arranged differently, they're bonded differently, and therefore the compounds are actually different. The molecules have their atoms, they have the same atoms, but in a different order. And that order makes them a different compound with differing chemical properties, which might be slightly different or very different. Isomerism is broken down into two general groups: structural isomerism and stereoisomerism. Structural isomerism is broken down even further, and that will include positional isomerism, functional group isomerism, and chain isomerism. Let's take a look at those one by one. We'll start with positional isomerism. So in positional isomerism, the functional group of the compound is in a different position in one isomer to another isomer. Let's think of a couple of examples. So let's think about the example of 1-chlorobutane and 2-chlorobutane. A chlorobutane is a butane molecule which has one of the hydrogen atoms substituted by a chlorine atom. It has chlorine in place of a hydrogen. In 1-chlorobutane, the chlorine atom is bonded to a carbon on one end of the butane chain. But there is another possible arrangement, another possible isomer with the same chemical formula that has the chlorine bonded to a carbon partway along that chain. In that case, it's 2-chlorobutane because the chlorine would be attached to the second carbon along the chain. These compounds have exactly the same formula. They actually have very similar properties, but they are different from each other. They are chemically different, they are structurally different, and they have different names: 1-chlorobutane and 2-chlorobutane. Let's consider another example, and in this case, we're going to consider the functional group of a double bond, and we're going to talk about but-1-ene and but-2-ene. These are both alkenes. They both have 4 carbons in a straight chain, and there is one position where there is a double bond between 2 adjacent carbons. In but-1-ene, that double bond is between the first and the second carbon in that chain. In but-2-ene, that double bond is between the second and the third carbon in the chain. Again, these two isomers have very similar properties. They have exactly the same molecular formula, but they are different and they do have some chemical differences. And in both these examples, and in fact in all the examples of isomers we come across, it's going to be important when you come to doing assignments and exam questions that where isomers exist, that we're able to name isomers by the structure that we're given, or that we're able to show the structure of a given isomer name. The next type of isomerism we're going to talk about is functional group isomerism. And this occurs where two compounds have the same molecular formula, but the arrangement is so different, they actually have different functional groups. Now, the most common example we use for this, because it's quite simple, is the comparison between ethanol, which is an alcohol, and methoxymethane, which is an ether. They both have molecular formula C2H6O. In ethanol, we have one carbon with 3 hydrogens bonded to it, and that carbon is also bonded to the other carbon, which has 2 hydrogens bonded to it, and a hydroxyl or OH group, and that's the group that makes it an alcohol. In methoxymethane, we have one carbon that's got 3 hydrogens bonded to it, and then that fourth bond from that carbon is to the oxygen. The oxygen's other bond is to the other carbon, and that second carbon also has 3 hydrogens bonded to it. So 2 carbons each have 3 hydrogens bonded to them, and the oxygen is bonded to both carbons. It's in the middle of that chain. So ethanol and methoxymethane have very different chemical properties, but exactly the same molecular formula. And in fact, that's frequently going to be the case when we're talking about functional group isomerism, because the functional group dominates the chemical properties of a compound. In functional group isomerism, the two isomers are going to be quite chemically different. The third type of structural isomerism is chain isomerism. And this is where we will have two molecules with exactly the same molecular formula, of course, but the way that the carbons in the chain are bonded differs from one compound to the other. A good example of this would be butane and 2-methylpropane. Both have the formula C4H10. In butane, all the carbons are bonded in a straight chain one to another, 4 carbons in a row. In 2-methylpropane, there are 3 carbons bonded in a row, but the second carbon, the one in the middle of that chain, is also bonded to another carbon. So that carbon is actually bonded to 3 different carbons. There's a side chain in that molecule, and that's going to affect the chemical properties, and of course, it is a different compound. That's the 3 types of structural isomerism. We're now going to look at stereoisomerism. In stereoisomerism, there are 2 types. We have something called EZ isomerism, and we have optical isomerism. Let's start with EZ isomerism. And if you're accessing an older book or other older resources, or maybe your teacher learnt chemistry many years ago, you may hear or see this referred to as cis-trans isomerism. It's exactly the same thing, but the proper chemical name that gets used is EZ isomerism. This isomerism occurs when there is a double bond between 2 carbons in a molecule. A double bond between 2 carbons is rigid. There is no rotation where there is a double bond. The 2 carbons are physically unable to pivot their position relative to the other, and therefore the other atoms attached to them, bonded to them, are in fixed positions relative to each other as well. Another prerequisite is that each carbon in that double bond has to be bonded to 2 other different things. If it's bonded to 2 things that are the same, say 2 hydrogens, then this kind of isomerism can't occur. Let's look at an example. And we're going to use the simple example that, again, is one that comes up very often, of a small alkene that's been substituted with 2 chlorine atoms. 1,2-dichloroethene. This is a small alkene. It's got 2 carbons double bonded to each other, and each carbon is bonded to a chlorine atom each and to a hydrogen atom each. Now let's consider those chlorine atoms. Because their relative positions to each other are static, there are 2 possibilities that can exist. There's the situation where the chlorine on one carbon and the chlorine on the other carbon are as close to each other as they can be. If you were writing this on a piece of paper, they would both be going up the page relative to their respective carbon atoms. And there is the situation where those chlorines are further apart. So in this case, if we're drawing the structure, one chlorine is going up the page and one down the page from their respective carbon atoms. Where they're closest together, we call that the Z isomer. And where they're furthest apart, we call it the E isomer. The Z and the E come from German words. The Z comes from a German word meaning together, and the E from a German word meaning opposite. So we would write the Z in front of the name of the compound for the isomer where the 2 chlorines are closest, both going up the page. So that would be Z12-dichloroethane. For the other example, where one chlorine is written up the page and the other down the page, we call that E12-dichloroethane. That's how those isomers are written down formally. I would encourage that if you have any molecular molecules available that you can make, have a go at doing that and observe that the bond between the 2 carbons is rigid and that the positions of the chlorines relative to each other can be 2 distinct positions that can't be changed. So the other example of stereoisomerism that we mentioned earlier in the episode is optical isomerism, and that's quite a bit more complicated. We're going to do a full episode on just that later on in this series. So let's think about what we've talked about today. So we defined what isomerism is. It's where two compounds have the same molecular formula, but the atoms are arranged slightly differently from each other. We talked about structural isomerism and the three types, positional isomerism, functional group isomerism, and chain isomerism. We also introduced stereoisomerism and talked about the EZ or cis-trans isomerism. And we mentioned that there's also an optical isomerism that we'll talk about in detail in another episode. So that's all for this episode. I hope you've both enjoyed it and learnt something from it. That would be great to hear from you about that. As always, it'd be great to hear from you. And one way of doing that is to find me on Instagram. I'm at Chemistry Made Simple. If you want to become part of the community and go deeper on this and other episodes and learn a bit more after the episode's been released and ask your question that's come up, please join me and other patrons on the Chemistry Made Simple community at Patreon/Chemistry Made Simple. Next time we're looking more at some organic compound types. Don't forget to subscribe so you definitely join me then. Don't forget to let your classmates know about this as well, in case they're not listening yet. Until that episode comes out, look after yourself, review what we've talked about today, look after yourself, and goodbye. Maybe what we've talked about today has sparked some questions, or you had some questions on this topic anyway, and you're still looking for an answer. Well, I'd go deeper and answer more questions for the show's patrons after each episode now. And you can become a patron very easily and for about what you'd pay for a coffee. You can find out more by going to patreon.com/chemistrymadesimple. That's patreon.com/chemistrymadesimple. And that link is in the show notes too. Once you're a patron, you'll find that I invite questions after each episode, so you're not left wondering. So I'll see you in that Patreon membership soon. Go there now.